The 1932 Deutz agricultural tractor, built in Cologne by Humboldt Deutz Motoren AG, marked an important step in early German diesel-powered farm machinery. As one of the company's first production tractors, it featured a robust, water-cooled flat-twin Deutz diesel engine, delivering 37 horsepower at the drawbar and 40 horsepower at the belt pulley. This efficient power plant gave farmers reliable performance for plowing, hauling, and stationary work. Known for its durability and simple mechanical layout, the 1932 Deutz tractor helped establish the brand's reputation for sturdy, practical engineering during a period when mechanization was rapidly reshaping European agriculture. The Kiowa engine, produced around 1950 by Kiowa Farm Machine MFG, represents an early era of small agricultural power units in post-war Japan. Rated at 3 horsepower at 800 revolutions per minute, it was designed as a compact and reliable source of mechanical and electrical power for small farm tools. This engine was likely mounted on a tiller, providing steady torque for soil cultivation at a time when mechanization was just beginning to replace manual labor in many rural areas. One of its notable features was its integrated electrical system. The Kiowa engine drove a small dynamo that generated the electricity needed for its ignition system. That power was sent to the igniter, which in turn triggered the spark plug and kept the engine running smoothly. This self-contained design made the engine practical for farms without access to external electrical power. Overall, the Kiowa engine reflects the durability and ingenuity typical of mid-century Japanese agricultural machinery. The Sachs Stamo 75, equipped with an Eismann generator, is a compact, reliable power unit typical of early 1960s German engineering. Manufactured in 1962, it features a sturdy 2-stroke engine producing roughly 1.8 to 2 horsepower, giving it enough strength for light industrial or field use. In operation, the Eismann generator delivers about 0.8 kVA at 3.65 amps, making it suitable for powering small tools, lighting, or instrumentation. Known for easy starting and dependable running, the Stamo 75's smooth operation and modest fuel consumption made it a practical portable power source for workshops, farms, and service technicians of its era. The 1,500 kilowatts Cummins diesel generator set is undergoing a full load bank test, demonstrating its reliability and strong performance for heavy-duty standby power applications. Built in 2008, this unit operates at 277 480 volts, making it ideal for commercial, industrial, or mission-critical facilities that require dependable backup power. With only 377 hours since new, the generator has seen very light use and remains in excellent mechanical condition. During the load bank test, the generator is brought through incremental load steps to verify proper voltage stability, frequency control, cooling efficiency, and overall power output. This ensures all components, from the engine to the alternator, perform as intended under real-world electrical demands. The low hours, combined with Cummins' reputation for durability, make this unit a strong option for anyone seeking a high-capacity standby generator that's been well maintained and thoroughly tested for operational readiness. The HATS E75 is a compact, air-cooled, single-cylinder diesel engine designed for applications where reliability, fuel efficiency, and durability are essential. Part of HATS's well-known small engine lineup, the E75 emphasizes simplicity in construction while maintaining strong performance for its size. It typically features direct fuel injection, allowing for efficient combustion and lower fuel consumption compared to older small diesel designs. Its air cooling system reduces maintenance requirements by eliminating the need for a liquid cooling circuit, making it particularly suitable for harsh or remote operating environments.
Well, that wasn't too difficult.
Despite its small displacement, the E75 produces consistent torque across a wide RPM range, which makes it useful for powering generators, small construction equipment, pumps, and compact industrial machines. Its robust construction, including a heavy-duty crankshaft, durable cylinder materials, and straightforward mechanical controls, contributes to a long operational life, even under continuous or demanding workloads.
I guess the price is no object. That's easy.
The engine is also known for relatively low vibration and noise levels for a single-cylinder diesel, thanks to careful balancing and optimized combustion characteristics. Many users appreciate its ease of servicing, with accessible components and a design focused on minimizing downtime. Overall, the HATS E75 engine is valued for its balance of efficiency, dependability, and versatility in small engine diesel applications.
Bit of a hopper. Does appear to be a small fuel leak here.
The JUMZ-1971 engine produced for the Soviet-era YUMZ tractors is a durable and straightforward power plant known for its reliability in demanding agricultural and industrial work. This diesel engine, often found in models like the YUMZ-6, was designed with simplicity and ease of maintenance in mind, qualities that made it popular across farms and construction sites throughout Eastern Europe. The 1971 engine is a four-cylinder, naturally aspirated diesel unit with a displacement of roughly 4.75 liters. It delivers modest horsepower but provides strong low-end torque, ideal for heavy pulling, plowing, and powering auxiliary equipment. Its fuel system is fully mechanical, which allows it to operate dependably even in harsh conditions and makes repairs manageable with basic tools. One of the engine's notable characteristics is its rugged cast-iron construction, contributing to long service life and resistance to wear. Although not as fuel-efficient or clean-running as modern engines, the JUMZ-1971 remains valued by enthusiasts and operators who appreciate its straightforward engineering. Today, the engine continues to serve in restored machinery and remote regions, where reliability and easy repairability are more important than modern technology. Its reputation reflects an era focused on practicality, durability, and accessible mechanical design. The JUMZ-6 tractor, produced around 1982, is a classic example of durable agricultural machinery from Eastern Europe. Designed for small to medium-scale farming, it is valued for its simplicity, reliability, and robust construction. At its heart, the JUMZ-6 is powered by a four-cylinder diesel engine, the D65, with a displacement of approximately 4.94 liters. This engine delivers a rated power of 60 HP, 44 kilowatts, providing sufficient torque for a range of agricultural tasks, from plowing and harrowing to towing equipment. Its diesel design emphasizes fuel efficiency and longevity, making it suitable for extended daily use in the field. The tractor features a straightforward mechanical transmission, allowing ease of maintenance and repair even in rural areas, with limited technical support. Its chassis and drivetrain are built to handle rugged terrain and heavy loads, reflecting the utilitarian approach of its era. The JUMZ-6 is often appreciated for its versatility, capable of operating various implements, and its low operational costs contribute to its continued use in some regions decades after production. While it may lack the comfort and electronics of modern tractors, the JUMZ-6 remains a symbol of practical engineering, embodying the durability and simplicity that characterized agricultural machinery of the early 1980s. The Tatra 148 V8 6x6 with crane is a robust Czech heavy-duty truck designed for off-road and industrial tasks. Featuring a V8 engine, six-wheel drive, and a mounted crane, it excels in transporting heavy loads and handling construction or military operations in rugged terrain with reliability and power. A two-stroke V8 engine is a unique and highly specialized internal combustion engine combining the compact power of a V8 configuration with the high revving efficiency of a two-stroke cycle. Unlike traditional four-stroke engines, which complete a power cycle in 4 strokes, intake, compression, combustion, exhaust, a two-stroke engine completes this process in just 2 strokes, allowing it to produce power with every revolution of the crankshaft. This design effectively doubles the power output relative to engine displacement, making it extremely potent for its size. In a V8 layout, the engine has 8 cylinders arranged in 2 banks of 4, forming a V shape. This configuration provides a balanced distribution of power and smooth operation, while also allowing for compact packaging compared to an inline layout. When combined with the two-stroke cycle, the engine achieves high power-to-weight ratios, which is why it is sometimes used in high-performance marine applications, racing vehicles, and specialized industrial machinery. The 1917 Hult tractor, featured in the video, is a remarkable example of early 20th century agricultural engineering. Rated at 45 horsepower, this machine was designed to provide reliable power for heavy farm work at a time when mechanization was still in its early stages. Its engine is rated to operate at 600 revolutions per minute, RPM, a speed at which it could deliver its full 45 horsepower output efficiently. However, in the video, the tractor is running at only about 325 RPM, significantly below its rated speed. At this reduced pace, the engine produces noticeably less power, demonstrating the relationship between RPM and horsepower in internal combustion engines. Despite this, the Holt's robust construction and large flywheel allow it to run smoothly even at lower speeds, which would have been useful for tasks requiring slow, steady power, such as plowing or pulling heavy equipment. The 1917 Holt is also notable for its rugged, durable design. Its exposed engine components, heavy iron frame, and steel wheels reflect the industrial approach to early tractors, prioritizing strength and reliability over comfort or speed. Watching this tractor operate provides a window into the evolution of agricultural machinery, illustrating both the ingenuity and limitations of early engines. Even at half its rated speed, the Holt remains an impressive and iconic piece of farming history. The open-crank four-stroke petrol engine, producing 11 quarters of a horsepower, was a 1920s marvel of simplicity and durability. Featuring an exposed crankshaft, air-cooled design, and hand-start mechanism, it powered small machinery and vehicles. Its robust construction and straightforward operation made it a reliable choice for early industrial and agricultural applications. The vintage diesel two-cylinder marine engine is a classic workhorse, known for its reliability and rugged simplicity. Often used in small boats and fishing vessels, these engines are prized for their durability and fuel efficiency. Featuring a straightforward design with two robust cylinders, they deliver steady, low-speed torque, ideal for marine propulsion. Many were built in the mid-20th century, and their cast-iron construction and mechanical fuel systems make them highly maintainable even decades later. Collectors and enthusiasts appreciate these engines not only for their functional performance, but also for their historical charm and engineering elegance. The 1929 Briggs & Stratton Phi flywheel ignition engine was a small, dependable single-cylinder power plant widely used in early lawn and garden equipment. Known for its simplicity, it featured a lightweight aluminum crankcase, mechanical flywheel magneto ignition, and a splash lubrication system that made it easy to maintain. Producing modest horsepower, it offered reliable performance for pumps, washing machines, reel mowers, and small industrial tools. The FI series helped establish Briggs & Stratton's reputation for durable, affordable engines during a period when small engine technology was rapidly advancing. Today, surviving FI engines are valued by collectors for their historical charm and mechanical straightforwardness. A complete rebuild of the Detroit Diesel 6-71 Marine engine is a substantial but rewarding undertaking, especially when adapting the power plant to match a vessel's drivetrain configuration. In this case, the core engine, pulled from the previous project video, had only one 240 original hours, making it an excellent candidate for a full teardown, inspection, and conversion. Originally configured as an RC right-hand rotation engine, the unit needed to be transformed into an LB left-hand rotation engine to properly align with the boat's existing gearbox and propeller setup. The rebuild process began with stripping the block to assess wear on liners, pistons, bearings, and the crankshaft. Even with the low hours, components were measured, cleaned, and either reconditioned or replaced to ensure the engine would perform like new. The rotation change required swapping and retiming the camshaft, adjusting the blower drive, reversing the firing order orientation, and reinstalling the marine gear accessories to match the LB configuration. Fuel and oil systems were also reoriented to ensure proper flow with the new rotation. Once reassembled, the engine was painted, tested, and prepared for installation. The result is a fully refreshed Detroit Diesel 6-71 Marine engine, now correctly configured to deliver reliable power and proper rotation for the vessel's drivetrain. The Detroit Diesel 6-71 is one of the most iconic and enduring diesel engines ever produced. Introduced in 1938 by General Motors' Detroit Diesel Division, it belongs to the famous 71 series, named for its displacement of 71 cubic inches per cylinder. As a straight 6, the 6-71 totals 426 cubic inches and quickly earned a reputation for toughness, simplicity, and reliability. Its two-stroke design, using a Roots-type blower for scavenging, became a recognizable hallmark, accompanied by the distinctive, high-pitched Detroit scream enthusiasts still celebrate today. During World War II, the 6-71 proved invaluable. It powered landing craft, tanks, generators, and other military equipment, admired for starting reliably in harsh conditions and running dependably under heavy loads. After the war, its popularity surged in civilian markets. Truckers, bus operators, and marine users embraced the engine for its durability and ease of maintenance. The modular design, shared across the 71 series family, allowed for straightforward overhauls and interchangeability of parts, making the engine especially attractive to fleet operators. The 6-71 produced roughly 165 to 238 horsepower, depending on configuration, but its strength lay in its ability to run long hours with minimal issues. In marine form, it powered fishing vessels, tugs, and pleasure craft. In industrial form, it served in pumps, generators, and construction equipment. Hot rodders and custom builders later found creative uses for the engine's robust blower, adapting it for high-performance gasoline applications. Although the advent of more efficient four-stroke diesels eventually displaced the 6-71 in mainstream use, its legacy remains significant. Many units are still running today, a testament to the engine's rugged engineering. The Detroit Diesel 6-71 stands as a symbol of American industrial innovation, an engine that helped power a century of transportation, industry, and maritime work. The 1933 Deutz MTZ 320 tractor engine represents an important stage in the early evolution of German agricultural machinery, combining rugged engineering with the efficiency advancements of the era. Built by Klockner Humboldt Deutz (KHD), a company already known for pioneering compression ignition engines, the MTZ 320 embodied the transition from steam and gasoline-powered farm equipment to more reliable diesel technology. Its design reflected Deutz's commitment to creating tractors capable of handling demanding fieldwork while keeping operating costs low.
Alors, sur le livre, ils disent qu'un enfant de 12 ans peut le démarrer. Ah, c'est vrai? C'est vrai? Ouais. Il faut déjà un enfant de 12 ans bien costaud, quoi. Ouais, c'est ça.
At the heart of the MTZ, 320 was a two-cylinder, air-cooled diesel engine, an approach that distinguished Deutz from many competitors who relied on water cooling systems. Air cooling made the engine lighter, simpler, and less prone to overheating or freezing, especially useful for farmers working in varied climates or remote areas where maintenance resources were limited. The 320's displacement and compression characteristics allowed it to produce steady torque at low RPMs, which was crucial for plowing, harrowing, and other load-heavy farm tasks. Although not powerful by modern standards, its reliability and fuel economy made it an appealing machine for small to medium-sized farms. Deutz designed the MTZ 320 engine with durability in mind. The robust cast iron components, straightforward mechanical injection system, and easy-to-service layout meant that farmers could keep the engine running with basic tools and practical know-how. Oil and filter access points were intentionally placed for quick maintenance, reflecting Deutz's understanding of real farming conditions. Vibration-damped mounting and an efficient flywheel further contributed to the engine's smooth operation. Beyond its mechanical features, the MTZ 320 stood as a symbol of agricultural modernization during the interwar period. It helped farmers shift from animal-powered labor to mechanized farming, improving productivity and reducing physical strain. Today, surviving MTZ 320 engines and tractors are valued by vintage machinery collectors for their historical significance, unique air-cooled design, and the role they played in shaping early 20th century agricultural progress.
C'est bien, on a la bouée, je suis bien content.
Et puis là, ça fait du joli labour.
Ouais, ça fait la fin, c'était dans la minute au départ. Ouais.
Nordhorn 2015, 24 MTZ, 1 MTH.